Hello, one and all. Welcome to another TG video entry. Notice how I didn't say the video entry number because, hey, I'm tired of that already. And in this video, we are going to be hopping into one of the derivative rules, which is the product rule. Now, before we get into some practice problems, I have written out the formula for the product rule, which is f prime of x times g of x plus f of x times g prime of x. So make sure you memorize this formula when doing the product rule. It will come in handy. Let's start off simple here. So we want to find the derivative of x squared times e to the x. Now, if you watched my previous video, I know that I have denoted derivatives as f prime, but you could do it either way, either f prime or d over dx. It doesn't matter. Both work. Okay, now going into the problem, what we could do is we could label x squared as f and mark e to the x as our g. And I'll move to the top right corner here. We can write out f of x equals x squared and g of x equals e to the x. Now we could derive these functions starting with f of x, f prime of x, taking the derivative of it, that gets us 2x, and deriving g of x, that gets us e to the x. Now, one important thing to remember is that the derivative of e to the x is always itself. So keep that in mind as you're deriving that function. Now that we have the necessary information, we could write it out in our product rule formula. So we will write it out as 2x times e to the x plus x squared times e to the x. Now we can multiply them together. It wouldn't really be much for both the left hand and right hand sides. So starting off with our left hand side, it would just be 2x times e to the x. And for our right hand side, it would just be x squared times e to the x. And this right here would actually be our final answer. So as you can see, this problem wasn't too difficult, but as you go deeper into your calculus career, you will encounter harder problems, as you might with this video, so stick around. Let's work through another problem here. So we want to find the derivative of x cubed plus 4x times 7x squared minus 1. So like previously, we could label this first function as our f and this second function as our g. We could write it out, f of x equals x cubed plus 4x, and g of x equals 7x squared minus 1. And we could derive these functions starting with f of x. F prime of x would equal 3x squared plus 4, and g prime of x would equal 14x. Now that we have a constant in g of x, the derivative of that would just be 0. The derivative of any constant is 0, remember that. Plugging this information in to the product rule formula, it would be 3x squared plus 4 times 7x cubed, 7x squared minus 1. What was I thinking right there? Plus x cubed plus 4x times 14x. Now that we have our product rule formula, we will want to multiply these all together. So what we could do here is distributive property, starting with the left-hand side. We could distribute 3x squared first. That would simply get us 21x to the fourth minus 3x squared, and doing the same for 4, that would get us plus 28x squared minus 4. I'll put this in parentheses here. And doing this with the right hand side, we would distribute 14x. 14x times x cubed would be 14x to the fourth. 14x times 4x would be 56x squared. Let's combine like terms. I'm going to rewrite this whole thing as we do so. So let's do it. 21x to the fourth plus 14x to the fourth would get us 35x to the fourth. Now, when it comes to x squared, we see that we have 3 terms with it. And combining those 3 terms, negative 3x squared plus 28x squared, that gets us 25x squared. And adding 25x squared to 56x squared, that would get us 81x squared. And we only have negative 4 as the constant, so we could just write minus 4. And this would be our final answer. Bit of a long problem, but hey, the road ahead of us is still long. Let's keep going. Let's take the derivative of natural log x times tangent x. Feel free to pause the video and work on this yourself. Okay, now we could label natural log x as our f function and tangent x as our g function. Now we could write these out. F of x equals natural log x and g of x equals tangent x. Taking the derivatives of these functions, the derivative of f of x would just be 1 over x, and the derivative of g of x would be secant squared x. Plugging this into our product rule formula, it would get us 1 over x times tangent x plus natural log x times secant squared x. Multiplying these together, starting with the left-hand side, 1 over x times tangent x would get us tangent x over x. Multiplying the left, no, not left. What am I doing, man? I've been watching too many Twitch streams. Okay, with the right-hand side, that would get us natural log x times secant squared x. And this right here will be our final answer. So if you were able to work through this problem yourself, good job. If not, that's okay. We still have a few more. So we have another function that we want to take the derivative of, 2 cotangent x times x to the fourth plus 6x squared. Feel free to pause the video and work on this yourself, but you don't have to. I'm not forcing you. So we could label 2 cotangent x as our f function, and our second function, x to the fourth plus 6x squared, as our g. We could write them out. F of x equals 2 cotangent x. G of x, that's a bad g, equals x to the fourth plus 6x squared. And we could take the derivative of these, starting with f of x, f prime of x equals negative 2 cosecant squared x. And g prime of x would equal 4x cubed plus 12x. Let's plug these into our product rule formula. Doing so, that would get us negative 2 cosecant squared x times x to the fourth plus 6x squared plus 2 cotangent x times 4x cubed plus 12x. We can multiply them together now. Starting with the left-hand side, we could do distributive property. Negative 2 cosecant squared x times x to the fourth is negative 2x to the fourth cosecant squared x. Negative 2 cosecant squared x times 6x squared would be negative 12x squared cosecant squared x. And we could do the right-hand side now, same thing. 2 cotangent x times 4x cubed would just be 8x cubed cotangent x. Running out of space, I'm panicking here. And 2 cotangent x times 12x would just be 24x cotangent x. Oh, I forgot to include a plus sign. So this would be our final answer right here. This big thing right here. Let's move on to one last problem. Let this function right here be our last problem. So we want to find the derivative of 2 natural log x times 4 cosecant x, and doing the same steps like we did previously, label 2 natural log x as f, label 4 cosecant x as g, write them out. F of x equals 2 natural log x. G of x equals 4 cosecant x. Taking the derivatives of these functions, f prime of x would equal 2 over x, and g prime of x would equal negative 4 cosecant x times cotangent x. Now let's write them in our product rule formula. So it would be 2 over x times 4 cosecant x plus 2 natural log x times negative 4 cosecant x times cotangent x. Let's multiply them together now, starting with the left-hand side. 2 over x times 4 cosecant x is 8 cosecant x over x. Working with the right-hand side here, 2 natural log x times negative 4 cosecant x times cotangent x is negative 8 natural log x cosecant x times cotangent x. And this right here would be our final answer. Okie dokie. That's going to be all for this video. I really hope you enjoyed it and learned something from it. And if you did, feel free to like, subscribe, and hit that bell. And leave feedback in the comments section, whether it's positive feedback, constructive feedback, or any other math topics you want to see. that's going to be all from me for right now, and I will see you in the stars. Or, well, in the next one.